Okay, here we go. Are we ready?
No, I just cannot stop playing with this thing here.
Kind of a personal problem, but okay.
Yeah.
Increasing and decreasing functions. Increasing and decreasing functions. Now, count the page taken. Increasing and decreasing functions are done from left to right. That's the way you read them. And then increasing and decreasing according to the x values. X values. X values are important. Okay? A constant level. Constant means it's level and it's unchanging. As you look at this lovely little picture, yes, I've drawn people on it again. In high hopes that you would understand that we're on the x values, which means we're on the domain values, yes. And you are literally at the bottom of the hill, and you look up it, and you say, I'm inclining, so I'm increasing. I walk up, 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 and then I get to the top, and I say, oh, I'm home. There's my house. I built my house on level ground. That's a constant value. And then I go down the hill to go get the ball that just rolled down. You with me? That's decreasing. From left to right. From left to right. Left to right, only x. Do I care about y's? I do not care about y values. I care about x values. You may have an x coordinate that corresponds to a negative y value. Do I care about that negative y value? No. Thank you all for listening. Moving right along. Maximum. Point on the graph where it is the highest value. I want you to refer to these as the humps on the camel's backs, or ain't no mountain high enough. Yeah, mountains. Did she? Mountains. Think of the camel. We riding on the camel. Now we have something called a relative maximum. A relative maximum is not the highest hump on the camel's back, but it is a maximum value, meaning it has a mountain. You have little hills, you got little big old mountains. Not all mountains are the same height. Some of them are the relative ones, some of them are absolutely the highest ones. Does that make sense? Now if we have a maximum, we have minimum. Ain't no river wide enough, ain't no valley low enough, keep me from you. Come on, that's a song, let's say something. Nobody cares? No. The maximum is going to be your mountain, minimum is going to be your valley. Valley. That's magical.
I gotta say that it's such a creepy game for me to college. It sounds so weird.
I agree. What's up, Rachel?
Not your killer. Sorry.
What?
Yeah, that is very sound.
Rachel,
Hate Winnie
I
the
should
Pooh.
call it Douglas.
Okay. Now, just. Okay. Okay. A drawing that looks something like that. This point right here is a relative maximum. Why? Because it's not the highest. Up here is the highest maximum. Yay, nay?
Yep.
What is this one down here? The lowest min, and what's this one right here? The relative min. Do we all understand that? Yay, nay? Now, understand that whenever we're doing max and mins, those are at points on the graph. They are points, which means they are x coordinates and y coordinates. Okay? Now, you're going to get a little bit confused today between open intervals and points on the axis, okay? When do you have a point? No. When do I have a point whenever I'm doing notation-wise? How can I tell the difference between open intervals and a point? Now, an open intervals use parentheses only, not brackets. Okay? So basically what this means is you don't have to ask yourself the question, okay, can it be 3 or can it not be 3? Do I need to have that as open or do I have to have that as a bracket? Okay, you don't have to ask yourself that question. And the next thing, when do we have ordered pairs? Ordered pairs only go with max and min values. Only used with max and min values. All other parentheses with a comma in them are going to be intervals. Do we all get that, yes or no? Okay. Let's have some fun, shall we? Anybody game? Let's do it anyway. Okay. I give you this lovely little picture, and yes, I am Picasso. Please call me Miss Picasso. It'll be fine, Picasso. My drawing is just
Yoder poo. Don't get upset.
Oh, that doesn't bother me. That's a nice thing that people call me.
That's the nice thing.
Okay, now, here's what we got to do. We got to go from, I'm telling you, that's nice compared to other stuff.
Not one.
You're evil. I see horns, you better watch. That's coming right up out of that head. Okay, now, we're going to do increasing, decreasing, and constant values. How do we read the graph? Left to right. So if I'm reading from left to right, I am clear down here at negative where? At negative infinity, do I see a graph? I do. As I march along, where do I stop increasing, decreasing, or constant? What am I doing? Am I increasing? Am I decreasing? I'm increasing. I'm going up the hill because here I am, right? I'm going up the hill, so I'm increasing. So as I approach up the hill, when do I stop increasing? So I am increasing starting at negative infinity to negative 3. And I'm using just the x-coordinate. Did you eat? That's your lunch?
No.
Sorry. Okay. Grab a computer and start listening to yesterday's video. Okay, so I stop increasing at the x value, negative 3. Do I care about the y value? No. What happens at negative 3 once I get to the top of the hill? What happens once I get to the top of the hill? What is it? It's level, it's constant. So when does it stop becoming constant? When it hits the x value, 6, right? So from negative 3 to 6, it's constant. Now understand, what are these? Are these points or intervals? They're intervals, okay? Then what happens once I get to the end of, at 6 there? I start decreasing from where? Starting at 6 to where? Now, how many do you think that should set, instead of infinity, be negative infinity?
Yeah.
Okay, it's not negative infinity. It is positive infinity because why? I'm dealing with my x values. So as x goes from here, negative, all the way across, 0, all the way up here to 10, 15, 20, 30, it is corresponding to a negative y coordinate. But the x coordinate of that point on the graph is positive. Do we understand why it's going to be to positive infinity?
Yeah.
Yes? Do we get that now? Any questions over constant, decreasing, or increasing so far? Excelente. Now remember, I'm a math teacher. Drawing is not my thing. I am. I am Picasso's cousin that is trying to ignore.
Okay.
Okay? So draw this lovely little thing on there. So the first thing we want to do is, notice I have a whole bunch of points there. So how about we go ahead and get some points on there? What's this point right up here? 2, 4, 6, 8, 10. Negative 10 to 2, 4, 6, 8. So I have the point negative 10, 8. Yes? This point is 2, 4, 6, so that's negative 6, 0. This one is 2, negative 2, negative 4. This one's 0, 0. This one is going to be 2, 2. This one is going to be 5, 2. This one is going to be 7, negative 1. And this one right here is going to be 9, 2. Okay? Now, why did I put all those points on there? 2 reasons.
Might as well.
One, so that you could draw it easier. Something that looks like that. Okay? And 2, in order for me to do increasing, decreasing, constant, I have to have what type of values first? I need to have my starting and stopping points, right?
Yeah.
My starting and stopping points are going to be the humps on the graphs, right? And the valleys. Mountains and valleys, mountains and valleys. So, what is my maximum value here? Sorry? Negative 10, 8. Do I have any other maximum values? Is it a hump? It is or it isn't? It's constant there, right? It's not a hump. It's level. Okay? So at 10, that's pretty much my only hump I got, isn't it? All right, what about my minimum? My minimum is going to be negative 2, negative 4. And do I have another minimum? 7, negative 1. So if I'm going across here from left to right, do I need this point up here? Do I need this point negative 10, 8? Do I need negative 6, 0? No, it's just on the graph, right, as a reference. Do I need negative 2, negative 4? Did it change direction there? It did. Do I change direction at 0, 0? It's not needed. Did I change direction at 2, 2? I did. I remained constant there, so I need that point. Do I change direction at 5, 2? I do. I change direction. I go down. Did I change direction at 7, negative 1? Yep. And how about 9, 2? Nope, I didn't. So do you see those 4 points that I've highlighted up there? That means I have 4 different regions for increasing, decreasing, or constant. Does that make sense? What we have to do is put those on the graph using interval notation. So increasing, constant, and then decreasing. Okay, so I'm going to start in which direction here?
Left to right.
Okay, so as I'm going down, oopsie. I start at the point negative 10, 8. And am I going up or down? Increasing, decreasing? I am decreasing, so I start to go down the hill. When do I stop going down the hill? At negative 2. So at this point, I'm going to decrease from negative 10 to negative 2. Do we see that? Is that an ordered pair, or is that a interval? I'm going to let you log on.
No, I have to work yesterday. Perfectly fine. It was the first time yesterday, so I don't know if there's any trouble.
You log in there for a minute so she can listen to the video. Okay. Now, what happens at negative 2? It increases. So from negative 2 to what?
2.
So from -2 to 2, it increases. And then what happens at 2? It stays constant. Okay? So it stays constant from where to where?
2 to 5.
From 2 to 5. And then what happens at 5? It decreases to where? So how do I denote another section of increasing or decreasing? The U. So I'm going to have U, and then from 5 to 7, it goes there. And then what happens at 7?
It increases.
It's going to increase again. To where? Okay, so from 7 to infinity. Do we understand increase, constant, and decrease? Max and min. What, Kat? Okay, do we understand this part right here? Any questions? Okay, next order of business. Write that down. Okay, an even function is symmetric with respect to the y-axis, and the following must be true. F of x has to equal f at negative x. An odd function is symmetric with respect to the origin, and the following must be true. F at negative x is equal to negative f of x. I'm sorry?
Someone knows that one.
Did you take some?
There was them two there and the other half of that one I need to get up there.
We still need them. I'll give you the other.
It's fine.
Are you okay with it?
Yeah.
All right. An odd function is symmetrical according to the origin. Here's the thing. If it's an even function is x squared, which looks like a parabola. If you fold it over the y-axis, right down the middle of the graph, it'll lay directly on top of it. Directly. Okay? Right on top. Every single thing. Now, a function that is odd is like y cubed. What do you have to do with this one? You fold it in half, and you fold it in half again. That's folded over the x and over the y. You're going to have to try to figure it out in a minute. I got to finish them up. Okay, do we understand this? That's how you can tell algebraically. Fold it in half again. Okay, that's an odd function. Now, how do I know if something isn't an odd or an even function? For example, I'm going to do one actually off tonight's homework, which if I can find tonight's homework. X cubed minus 3. I want to prove that this thing is an even or an odd function. Okay? If it's an even function, I have to prove that f of x, which is the original function, is equal to f at negative x. So f of x is this. I have to prove that those two are equal. So what do I have to do in order to do that? What do I have to calculate? Do I know f of x already? F of x is given. In this case, it would be h of x, it's the same thing. I have to calculate f at negative x. So what I'm going to do is every place I see an x, what am I going to put in for it? Negative x. So a negative x times a negative x is an x squared times a negative x is what? Negative x cubed minus 5. Now, here's the question. Does f of x, which is x cubed minus 5, equal my negative x f of x, which is this? Do those two things equal? No, so therefore it is not even. It is not even. So now I have to figure out if it's an odd function. Well, by definition of an odd function, I have to prove that f at negative x is equal to the negative times f of x. Okay? Which means I'm going to take negative f of x, which I already know, I already calculated that. And now I have to do the f at negative x, I'm sorry. I have to distribute the negative into it. Well, that was going to be negative times x cubed minus 5, which is negative x cubed plus 5.
So,
Yeah, I mean, that's what you're talking about.
Okay, now, guys, all you have to do is do two things, okay? To determine if something is even or odd, you have f of x, f at negative x, and negative f of x. Those are the three functions you have to compare. That's it.
I'll come up better day.
That's it, okay? If I give you the function to be x cubed minus 5, that's the original f of x. Do we understand? I have to calculate f at negative x. So every place I have an x, what do I put in for it? Negative. So this is negative x cubed minus 5, which is negative x cubed minus 5. Do we see that? A negative times a negative times a negative is still a negative. Yes?
Yep.
Does everybody get this? Okay. Now, all this means with the negative in front is I'm going to distribute the negative. Yes? So here's the negative 1 times my original f of x function. If I distribute that, that gives me negative x cubed plus 5. Do we see that? So, there's my three functions. If it's an even function, then f of x has to equal f at negative x. Do these two equal? Do they equal? No, so it's not even. To be an odd function, then that has to be f at negative x has to equal negative f of x. Do these two equal? So is it an odd function then? It's not odd. So if it's not even, if it's not odd, then what do I know? It's neither. In other words, I cannot fold this any way for it to be an even or an odd function. Okay? What time are we out of here? In 3 minutes. Okay, where is my worksheet? I didn't leave it. No, not that.
Sunday is dedicated to I'm gonna just treat it like I'm like
Yeah, you get
I'm
home,
gonna do everything.
you get home, the worksheet playing.
I really need it.
Okay, are we listening? Are we listening? Pay attention. All right, the front part of the worksheet is what I already talked about, increasing, decreasing, all of that. I give you the graphs on the top 4, and then you have to graph the bottom 4 yourself. Okay?
You want to actually graph it?
You can just use the graphing calculator and look at it. Okay, I want all the information on here. Now, turn it over. Problem 7 and 8, I did not get to go over. Okay? 9 through 14, I did go over. Okay, just now, even odd and either. That's what you're going to do for 9 through 14. And 15 through 18, we'll talk about on Monday. So 7, 8, and 15 through 18, we'll talk about on Monday. The rest of it, you guys should be able to do. Any questions?